Hello everyone, today we're going to be going over this IB math question, which should be most appropriate to AA, but I believe it's in the content of both AA and AI courses. I'm not going to say whether this is SL or HL because I have no idea what the gap of difficulty is between the two, so I'm going to leave you to work that out for yourself. If you're SL, try it anyway, because it will only make you better at math. Anyway, it's been a while since I made the last video, and then this YouTube channel is part of my CAS in the next 2 years, so I will be continuing making videos in this. So we're going to go with this question from a paper from 1996, which is determine the coefficients of 1 over x and 1 over x squared in the expansion of this binomial series. So how do you figure out the answers to these kinds of questions, where it says determine the coefficients of some power of x in some series? Well, generally, the first step of the process, if it's not initially obvious at what number term the x to the something power would be, you should create a formula for the general term, the general nth term, basically. So you'd go like the nth term is, well, given that the first term of this binomial is x and the other one is 1 over x, it would be something like 9 choose n times the first term to the power of 9 minus n times the second term to the power of n. And this might simplify down to something a lot simpler, given that everything else is in terms of x. So x to the power of 9 minus n multiplied by x to the power of negative n, it would be x to the power of 9 minus 2n. So now we know that this is our nth term, and we are looking for x to the power of negative 1 and x to the power of negative 2 here. We can substitute negative 1 being equal to this expression and negative 2 being equal to this expression to figure out which term it is in the series. Now the thing is, you may notice these are 1 apart, but the exponent in the series goes up in steps of 2, or rather down in steps of 2. So how do we deal with this? Well, we don't. For example, if we're saying the exponent is negative 1, and this is our first question being asked, if we say it's negative 1, minus 1 is 9 minus 2n, or 2n is 10, n is 5, so of course this is the 5th term, and we get something like the coefficient is 9 choose 5, which you can either use the calculator or you just do it manually. 9 times 8 times 7 times 6 times 5 over 5 times 4 times 3 times 2 times 1. Now, you may have noticed that this is actually a pretty roundabout way of going about it, because 9 choose 5 is going to be equal to 9 choose 4. Like if you have 9 choose 3, for example, it's equal to 9 choose 6, because 3 plus 6 is 9. You can kind of see this from the fact that the 5s are just canceling out. When you keep going down the numbers here and up the numbers here, they'll just keep canceling out. Anyway, the 6 cancels with these two here, and the 8 cancels with the 4 here, leaving just 2. So it's 9 times 2 times 7, which should be something like 126. So this is the coefficient of the x to the negative 1 term. And now, the other part of this question is somewhat of a trap. Don't expect the coefficient to always be an actual number, like it can be 0, because the term for that exponent of x might just not be there. So in that case, you would say the coefficient for 1 over x squared, for example, is 0. And we can demonstrate this. If we make negative 2 equal to 9 minus 2n, and this of course means that 2n is 11, n is 11 over 2, you would say that since n should be an integer, this is the z, the integer set, there is no 11/2th term of the series. Therefore, the coefficient is 0. Alright, that is the end of this question. I don't have the mark scheme for this, given that this paper is older than anyone who is possibly watching this video, I suspect. So, that's all for now. Thanks for watching.